Okay, it's 6:05. I think we can go ahead and get started. Well, good afternoon, everybody, and thank you for joining us for today's NOBCChE Post-Conference Collaborative webinar. It's a pleasure to have Serge Fort to join us from Corteva this afternoon, and we're going to be discussing academic and industry careers, presenting that from two perspectives, from the academic perspective and certainly from the industry perspective, where we're happy if that Serge can join us for that this afternoon. Just before we start, and especially since we have a smaller group to start with, we'd like to encourage everybody, introduction from the participants. And I guess I can start with myself. I'm Victor Ogungbe. I'm an assistant professor of chemistry at Jackson State in Jackson, Mississippi. And I certainly, I will tell you a little bit more about myself later on, but I guess maybe Serge can do a quick introduction and as well as the participants.
Yes, my name is Serge Fotso, and I'm a research scientist at Corteva AgriScience, and we are based in Indianapolis. And I've been working with the company for 12 years now.
Thank you, Serge. Ashley?
Hi, my name is Ashley Wallace. I served as the co-chair of NOBCChE's National Planning Committee this past year in 2020. And so I'm very thankful to Victor and Serge for agreeing to facilitate a discussion around careers. So thank you both.
Thank you, Ashley. Britt.
Hi, I'm Britt Morris. I am just a professional at this point. I was in grad school, but I'm looking to go back again to potentially get a career in academy or industry. I'd like to see a little more than what I've seen at the conference. So a big NOBCChE fan.
Thank you, Britt. Raymond?
Good evening, sir. Good evening, everyone. I am Raymond Hawiyemi, a PhD student of Mississippi State University. I'm currently on PhD chemistry. So I'm looking forward to a career in the industry or possibly in academia as well. So I just want to get enough information from this conference. Thank you.
All right, thank you.
You're welcome, sir.
Yeah. Kevin.
Good evening, everyone. My name is Tochku Kevin Eboluche. I'm a PhD student in Jackson State University, chemistry major. I'm looking forward for industry career after my graduation. Thank you.
Thank you, Calvin. Kizito Madu.
Yeah, hi. I'm Kizito. I recently just finished my PhD in Chemie at U of M, University of Michigan. I just wanted to hear some insights, I guess, from both sides of the sphere of academia and industry to kind of gauge where I want to go.
All right. Thank you. That's Niyakira Krishna. I can't say the entire name, but I hope I didn't. Okay.
I can introduce myself. Okay, my name is Niharika Krishna Bocha. I'm from India, but I'm doing my PhD here at the University of Alabama in Huntsville in material science. I'm in my final year and I'll be graduating this summer, and I'm planning for a postdoc and later hopefully an academic career if I'm still not fed up with this, or an industry career depending on how I feel after my postdoc. That would be good. Yeah, thank you.
Good, thanks. Dr. Waddell.
Hello, I'm Dr. Michelle Waddell. I'm an assistant professor at Hampshire University in the Department of Chemistry and Biochemistry. I don't know what else because I came in late when you were asking me to say.
It's just a brief intro.
Okay.
Yeah.
That's basically it. And I'm the advisor for the NOBCCchE chapter here at Hampton that was chartered at the National Conference in September.
Good to have you. Dr. Waddell. Tim? Tim? All right, so I guess that perhaps Tim is busy. So suddenly, since we have a smaller group, I thought it would be appropriate for us to at least get a quick introduction from everybody, and also have a kind of idea of what the participants, whether with their different levels, and also to get an idea of the best way to go about this webinar. So I'm going to start starting from the academic point of view and I'm going to start by just reviewing the role of the academia, and then move on to positions and certainly the responsibility of academia. Now, just to start with, I'd like to just talk a little bit about the collaborative, which is we're meeting under the NOBCChE Collaborative auspices this afternoon. And certainly the collaborative is a group of 6 institutions that we have representative from each institution that makes up the team, the current chartered team. And the intention of the collaborative, actually the main goal, is to have a network of like-minded professionals who are interested in certainly supporting the advancement of URMs in chemistry and possibly chemical engineering. And certainly to provide both opportunities for research, also for career advancement, to be able to make connections, networking. And this started a few years ago, and Dr. Renee Robinson at Vanderbilt has been the one spearheading the effort of the collaborative. And certainly Dr. Michelle Waddell at Hampton, she's one of certainly on the team, and myself, and certainly a number of good colleagues, Bakar Kanu at Winston-Salem, Dr. Ortiz at Auburn, Kristen Thomas at Ohio State, and Vince Ortiz at Auburn, and Tara Meyer at Pittsburgh. So if any of the participants you're interested in any of the programs in the schools, or you have interested in any opportunities there, those are individuals that you can actually reach out to certainly to connect with them, and also to build a network. With that said, I'm going to start by just looking at certainly the role of the academia. So what is the function of the academia? We start from here and then move on to positions, or what to certainly what to be aware of, or what to look forward to in an academic example. As perhaps everybody know that there are 2 basic roles of the academia, and number 1 is to produce new knowledge, which all of us would like to have new knowledge about different things, whether in the form of an applied science or basic science. New knowledge is what drives innovation and what makes our society better. And so the second thing is the second goal of the academia is to produce skilled individuals. In the context of producing skilled individuals, it could be at the associate level, at the bachelor's level, in the master's, at the doctoral level, or even the certificates for different skill set. And that you can obtain certificates even after your doctorate, depending on new areas of interest, and also of if you want additional credentials in some specific field. And for new knowledge, we know, especially in chemistry, we are interested in, for example, new synthetic methodology or new separation techniques or methods. Those are new knowledge, and people can use those and apply it in a variety of ways. And you might be interested in the understanding of the function of any biomolecule or molecule in the cell or in the atmosphere or in plants, and so on and so forth. Or the new knowledge could be in the form of new drug delivery methods. But regardless of what it is, the function or the goal of the academy really is to be able to do that. And certainly there are some secondary roles, which would be certainly to influence the local community, and by extension influence policy and things like that. But at the primary level, just at the fundamental level, we have those 2 functions. And anybody who is really aspiring to be in the academy or to work at universities or colleges your job is tied to these two main things: to produce new knowledge or to be part of new knowledge production, as well as to be able to train individuals regardless of the level. And the type of institutions or the university would determine exactly how much of these that you participate in. So if you're at a research university, there's a strong chance that your activities from day to day might be involved in producing new knowledge, or at least verifying or known knowledge. And then, yeah, if more so your research, your work is more associated with teaching or service within the university, then it's perhaps much more linked to producing new graduates in different disciplines. And in chemistry, we know that things evolve rapidly, and obviously we have to train students with respect to the latest technology and also innovation. As the saying goes, that at the university, all we do is just to study it, but then when we produce individuals, you want them to go get a job out there and actually apply that knowledge. And certainly, in the university, we still apply the knowledge, but mostly, what goes on is a lot of studying of new things. Now, if you consider the academy, and what I've tried to do here is just to try in a way to group to create three groups of the different types of institutions at the higher learning level. So we have we have the research institutions. So that would be research institutions. It could be research intensive or not as intensive, and we have the undergraduate institutions, which are universities where mostly it's more focused at undergraduate training. There's perhaps limited opportunities for research, or if there is research, it's not as intensive. And we also have the community colleges, which are typically geared towards producing technical skills, and in addition to people that are receiving an associate degree and can move on to a 4-year college for them to be able to get their bachelor's and so on. So the responsibility at each of these institutions differs a little bit, well, considerably, actually, depending on what type of, whether you have a research intensive or you have an undergraduate institutions. But generally, the responsibilities is around these 6 different things. And number 1 is teaching, research. There is opportunity to direct undergraduate research, direct graduate research, have a service component to the responsibilities, and as well as a consulting. Now, for research universities, certainly teaching as a faculty member or as an instructor, there's some teaching, but typically the teaching load is perhaps much more reduced compared to an undergraduate institution. So if someone is at an undergraduate institution, usually the teaching responsibilities are a lot more. Actually, most of the work is designed around teaching a significant number of courses, and that is also true for community college. There's a big component of community college is also the teaching responsibility. Now, for research, research institutions, as the name implies, also requires a good amount of research endeavors. Certainly, it could be research in an individual lab, or it could be part of a center or part of a wider national collaborative or project. But a lot of work at research institutions is directed, or at least you have a lot of opportunities to explore research projects. That is not as much, you don't have that much opportunity at an undergraduate institutions. Not to say that if you want to do research at an undergraduate institutions, that is not possible. It is possible, and there are programs designed for that. But those institutions are the goal, or at least the basic goal is not towards research. It's mostly towards training, towards teaching, and generally with a large undergraduate enrollment. Community college, there's not that much research at community colleges. There are some, actually more recently, I think there are programs where students at community colleges will try to introduce them to research, either through summer programs, summer research experiences. But as in terms of the primary responsibility of a faculty member or member of staff at a community college, research is not top and in terms of the list of things that needs to be done. The other thing is direct undergraduate research, and certainly at research institutions and undergraduate institutions, there is a lot of undergraduate research going on, whether in form of a course-based research or a summer research experience, or even during the academic year, you have undergraduate students who be involved in research with their mentors, with their faculty mentors, and you have a good number of that going on at research institutions as well as at undergraduate institutions. So the research that typically takes place that the faculty member might be involved with at an undergraduate institutions, actually a lot of it is linked to the ability or the opportunity to direct undergraduate research. At community colleges, again, there's not that much opportunity for that. Now, a lot of research institutions are geared towards training PhD, doctoral students as well as postdocs, and that means that the faculty member there will certainly be expected to run a lab to that where graduate students are involved in research and graduate students are being trained, and that it requires certainly a significant level of research for you to be able to train a PhD and a postdoc fellows for them to move on to their career. That you don't have that certainly at undergraduate institutions. There wouldn't be any certainly unless there are some undergraduate institutions where they have a number of graduate programs. So, but typically that is quite limited in terms of both the number of students and also the number of programs running a graduate program, but the vast majority of graduate training takes place at research institutions. And obviously that you don't have that at the community colleges. Now, part of the responsibility of most faculty members or members of staff at any of these institutions is to be involved in the university service, whether the university or the outside community. For example, being involved in NOBCChE, involved in ACS, involved in certainly perhaps the service learning opportunities in the local area, and or even on campus. So you have faculty members or members of staff who are part of the curriculum committee or safety committee or admission committee, or name the committee. And certainly a lot of this, the service could be a big component of one's responsibility, because sometimes it just takes a lot of time and you have to do that in addition to other responsibilities that you have. And that, as you know, service, you can do service at the research institutions, undergraduate institutions, as well as the community colleges. Now, for vast majority of research that are produced at research institutions, we know that depends on, for the most part, on the very cutting edge research in some cases, and also some certainly good amount of understanding and knowledge of the subject matter. So a lot of a good number of faculty members at research institutions also serve as consultants, whether to companies or to government, or to government would be local or national government as part of policy formulation. So you have faculty members also being involved as consultants. And in chemistry, that is actually quite a good number of faculty members at research intensive universities. Either is engaged in some research with a company, or as part of a team to help solve a challenging problem. Or in some cases, it could be that the company is interested in some of the technology that the faculty members are trying to develop, and they could be part of the at least the initial implementation team in form of a consulting role or as a consultant. You have opportunities also at the undergraduate institutions, but certainly because of the much less emphasis on research, then with the vast majority of consulting opportunities will probably be, for faculty members at research institutions. So this just kind of shows you, at least at the basic level, what are the responsibilities. This really has nothing to do with the administrative responsibilities, because then if there's a faculty member that also have some additional administrative role at the university, But in terms of, okay, what are the most common responsibilities that you will expect in academia, depending on the type of institution, these 6 things are things that are quite that are quite common. So the next thing I would like to touch on is the actual positions that you find in academia. So depending on the institution, what are the the most common positions that you're going to find in academia? Now, the first positions, certainly whether at research institutions or at undergraduate institutions or community colleges, are positions like instructors. So it could be instructing one course or several courses. It could be a large class or a smaller class and things like that. And typically, depending on the school, the title of the position can be an instructor, or it could be an adjunct professor, or in some schools it could be clinical professors. And all of these would be clinical professors of practice, where your responsibility might just be to teach the general chemistry class for for non-majors or for majors for the and that's the only responsibility. Or it could be an adjunct professor where you come in, some are kind of perpetual positions where it's adjunct for a long time, or it could just be for 1 semester, and then there's no teaching responsibility for another semester, and that means that person is not engaged. Or it could just be continuous. But a lot of institutions actually have more like a permanent instructor positions, and the instructor position is typically not a tenure-track position. It's a typically non-tenure-track position, but it could be permanent. It could be permanent, and that there are some university systems that actually make the teaching positions more like a tenure-track, which is although those professors are mostly involved in teaching and not research. Perhaps the more traditional track for positions in academia is the tenured or tenure track professors, right? So that's kind of the more traditional faculty jobs, where you have, starting from an assistant position and then going through evaluations and also promotion or evaluation at some point to associate, and perhaps from associate to full professor. With that, you find those positions at research institutions, at undergraduate institutions, and even at community colleges. Depending on the system of community college, the ranks could be the assistant, associate, full, or it could be instructor, and a mix of the different types of positions. But the goal here is for the tenure track means that the professor or the faculty member are tenured, so they more of a permanent job, and they're only going to lose their job if there is a severe budget shortfall, or maybe some type of a disciplinary event. But in any case, the ranks of instructors at most universities is beginning to, in terms of the proportion, is beginning to increase, from where it used to be, for example, in the 70s, because in some cases, those positions perhaps in terms of budget, they probably cost a little bit less than the tenure track positions, and a lot of universities, certainly for some of the lower level classes, well, I guess perhaps the big classes, the first year, second year, are probably taught by instructors. Apart from that, you also have research positions at universities, just like research positions at industry or government. And these research positions are different. It depends on the lab, and also depends on if you have a research center. So it could be research positions in the form of research professors, or it could be research positions in the form of a research associate or research scientist and the research technician. So depending on what lab it is and who is paying for the position, the name of that research position could be different. And the vast majority of these positions, you find those at research institutions, right? So if you have a big lab, typically a big lab in the research institutions is going to have PhD students, postdocs, which postdoc would fall under a type of research position. And also you could have a lab, a lab manager, or you could have some type of research professors in that lab, or a research scientist in that lab. And research scientists or research professors, depending on the funding for the lab or for the center, can be a long-term position, or it could be a short-term position. But those are kind of very common positions, research positions that you can find in the research institution. Certainly, there are some type of positions like the technical staff that are more permanent, and you can find all of these those positions in the three, I guess, broad classes of institutions. So it could be like stock lab managers, or it could be technical managers, lab managers for instrumentation labs, taking care of NMR, taking care of mass spec, and things like that. And certainly, some of those technical staff positions are quite a long-term job, unless their position is supported by some type of soft money, which is grants that last for so long, and then if it doesn't come back, then that means the person will have to transition to a different position. But that kind of just paint a picture of from a in terms of the common positions you will find in academia, more so in chemistry departments and so on. Now, how to get to those jobs? So I kind of made this for you to see that there is really no one, at least nowadays, there's really no one straight path to actually move up from, say, a graduate student. So let's say, for example, you have a graduate student. The more traditional way of, say, for example, getting a job in academia would be a graduate student will spend, after your graduate school, anywhere between 4 to 6 years, depending on the program, and how quickly you get able to get your research done or get your papers published, and move on to a postdoc position, right? That would be more traditional. And then after a few years of postdoc, anywhere between 2 to 5 years, depending on the institutions and if where you want to go, with whether the job market and things like that, you can transition to an assistant professorship. And from assistant professorship, that was a probationary period of between maybe 4 to 7 years, again, depending on the system and also depending on how productive or how quickly your research evolved. You can apply for promotion to be an associate professor tenured. And when you get here, then it's not just a case of, okay, do you have enough productivity and papers, graduating students getting grants to be able to move up to be a full professorship. And then you can, once you be, when you're full professorship, then perhaps the next thing after that is, in some institution, you could be a distinguished professor of this or chair, holds multiple, professorial chairs and until you retire, right? But that is kind of more traditional. That is kind of what it used to be, when there was still plenty of academic jobs and compared to the number of applicants or individuals who really would like to have this job. But things have changed drastically, and now we have a lot of different types of positions that you can transition into. And if you still want to go back, to be a tenure track professor, you can still go back on that track. And I kind of showed a few examples here. So let's look at the scenario. A scenario that if you're basically more interested in teaching, you just want to be an instructor, you don't want to be a teacher, you don't want to do research, you can, from graduate school, finish your graduate school, and then find get an instructor position, and you can be an instructor all you want as long as that position, they keep you there in that position, and you can be an instructor and until retirement, if that's what you like to do. But certainly, it all depends on the availability of that position and also the stability of the position. Of if a job opens up, if when you're an instructor, you can move up to a job of an assistant professorship and go through that probationary period, and then you move up, as the case may be. But the case might be from a graduate student, you just transition to be a research scientist in a lab, in academia, or in government, or in industry. And after a period of time, you can remain a research scientist, all your career, depending on the funder, right, or the stability of that position. And you can then still transition from a research scientist to an assistant professor and move up, or generally, the assistant professorship will be where perhaps it's not, at some point, you're gonna have to move up, right, for vast majority of people. The case may be that you probably have to do your postdoc, after the grad school before you get a research assistant job, or before you are a research scientist job, or you get an instructor job. But as the case may be, so all of these that you see here is just a case of, depending on your interest or the availability of positions, or, that would determine exactly which path that you really want to do. But if you want to remain in academia, you don't want to go to industry or don't want to work in government, as the case may be, then these are kind of the options available to you, certainly for you to be able to transition from graduate school to a position. And also for especially at research universities, you could finish your postdoc, move on to be a research scientist, and then in the same lab or or in the same institutions or another institution, you can then transition to a research professor position. So for the research professor positions, typically, also this is typically driven or mostly supported by soft money, which meaning grants, and you have to continually seek for money to maintain that position. And for some institutions, it's actually that you can actually be promoted from assistant, associate, full professor, and certainly with increased remuneration and also certainly maybe more responsibility. And you can be a research professor your career until you retire. So again, although that is not compared to the teaching jobs or to the teaching and research job is not as common, but that is something that a lot of scientists or chemists would like to do, just to do research in an academic environment. And the way to sustain that will be to be a research professor, and you can just do your research and publish. So one thing to touch on here is typically there's also some academic roles, or academic administrative positions. For example, the department chair or the dean, associate dean, a variety of administrative provost or whatever the case may be, an administrative position at the university, where typically those positions are from the faculty cadre, right? So and generally you get to be in those positions, but at least for your own career, if perhaps you are an associate professor already tenured, then you can now branch on to be an administrative, to be a chair, and you can remain chair for as long as your colleagues or the university wants you to be there, or you can be a dean for as long as, or if there's no time limit, and if there's time limit, you can be a dean for 5 years and then move back to your classroom to now teach, whether at the associate level or at the full professor level. So again, all of this, just shows the different possibilities that exist, and certainly there is no one, guarantee that anybody is going to be able to go, from graduate students straight into a postdoc to this. A lot of people do that, but also because of the job market and how certainly positions and what you really want to do. So even if you get an assistant professorship job and you don't really think that is a good fit for you, that you rather want to be a research professor or research scientist, then that could be a path that you would take. But regardless of the path that you take, all that it requires is just doing the work that is required and being able to, certainly in academia, being able to publish, being able to either compete for funding, certainly doing a good enough job at teaching, and certainly you are also enjoying the job itself. So I think I've got just one more thing to talk about, and then I can turn it over. Well, maybe just a couple more things, but because of time, I will try to limit it. So certainly, just to kind of give you an idea what you expect if you're a professor at a research institution, certainly what you do is maybe teach 1 or 2 courses per semester, or in some institutions, maybe per year. A professor at a community college is probably looking at maybe 4 courses per semester to teach. Now, in terms of research, professor is expected to do research and publish the findings, seek funding, actively seek funding to maintain the research lab, and certainly advise, trainings undergrad up to postdoc level, and services required, right? You have to service to the university, to the wider community, to the college. And if you're a research scientist at a research institution, so your job will be to do research and publish, work with your PI to be able to seek funding for the research lab so that the research keeps going. And certainly you most likely also have responsibilities to assist the PI to train undergrads and postdocs and perhaps PhDs. So I just thought I should mention this very quickly, for you to be able to transition to any of these positions, really, as a graduate student or as an undergrad. Things that you need to keep in mind is really that Without any, you really need to learn how to be a scientist or an engineer, and it requires the knowledge. You need to start your research, making sure you read and you keep reading so that you are vast in the, you have a good grasp of the field that you're working with. And also it requires a lot of time. So your research takes time. Schedule needs to be planned appropriately for you to get the most out of your research. And be sure to make a plan with your advisor and write it down. Write out the plan so that as you go through the plan, you're actually able to check things off and things quickly enough for you to make for you to change course. And certainly, it's good to present at research at conferences. Certainly, you meet people, you improve communication skills, learn how to write, properly proposals, reports, and papers, because those are the skills that you really need for any of those positions that you're going to transition to in graduate school. Money is good if you're applying for jobs and people see that you've been able to win fellowships or small grants, whether even travel grants. That is an indication that you probably have the training to be able to do well when they're evaluating your resume for positions. And lastly, perhaps more importantly, also, it's good to develop very good, how to manage interpersonal relationships. And as you work in the chemistry or chemical engineering lab, you have different people, different personalities, different backgrounds. They're learning how to be able to navigate. That also helps when you transition to an academic positions, because you have students from different backgrounds, you have colleagues from different backgrounds that you need to be able to have some level of collegiality and to navigate that, the interactions, so that the university can benefit from those diversity, and also you can be also make contributions to the group. So I think I'll probably leave questions to the very end if anybody has a question, but that's kind of things that I want to touch on in my section. Thank you, and over to you, Serge.
Can you see my slide?
Yes.
Okay. All right. Yes, thank you really for this opportunity to come and talk tonight a little bit about the career and what goes on in company or industry. Please bear with me. I will take these few first slides just to first present our company, and at the end just talk a little bit about the different field or opportunity that we offer. Yes, a little bit about myself. I started my study in Cameroon, in Yaoundé, Cameroon, which is in Central Africa, from my undergrad until the master there. And then I went in Germany where I did my grad study. And from Germany, I came here on the West Coast in Oregon for a postdoc. And then from there, I went to a company. Back then it was Dow AgroScience, and I was there from 2009 until we transitioned to Corteva, and I'm a natural product scientist there. And actually Corteva came from the merger between the Dow Chemical and the DuPont. And through that merger, 3 companies spun out. And we have the material science, which is the Dow Chemical, specialty products, which is DuPont, and the agricultural company division came out, and Corteva. And we are actually 1.5 years old, because that happened. We had a year last June. And who are we actually? I'm going to play a little bit of the video to give you an idea. Yes, as you guys saw from that video, we are a company, and that being said, we have our portfolio actually is in 3 key areas for agriculture: the seed, the crop protection, and then we also offer digital. That means everything we do really is just to help farmers to grow food. That's mainly what we do. And a little bit the number, the crop protection side and the seed side are around 50-50. And in 2018, we were more than, we had more than 14 billion in sale. And 50% of our business is in North America. Then the other 50% around the world. Although Asia show only 10%, there is a lot of growth in that area. And we have more than 20 people around the world, and we are in 100 and plus countries. And again, we deal with 10 and plus crop, going from wheat and alfalfa, canola, cotton, rice, really you name it. And we have around 65 and plus active ingredient. Our purpose actually is to enrich the life of those who produce and those who consume, ensuring progress for generations to come. What we look at Corteva, these are the different areas actually where we generally offer jobs. Engineering, really, whether it's chemical, mechanical, electrical, whatever, that deal with engineering. Science, you know, soil, agronomy, entomology, plant pathology, biology, biochemistry, chemistry, digital, developing software to help customer, commercial also, whatever is commercial, sales, marketing, communication, government affairs, public relations, all, and then business operation, human resource, legal, supply chain, manufacturing, all that. That's the different sector where if you go in our webpage, that link will be at the end where you can see what are the available positions in those sectors. Now, how is the work done in industry? Generally, every industry will have what they call the pipeline, and the pipeline is just the list of molecules that you have that will be coming out. And truly, from the time you make the discovery in the lab, through the time you launch it, it's a very long time. It will take you like 10 years, and it's very, very costly. You know, and this is just if you have an agricultural chemical. Now, if you go from the trade side, it's a new trade, it's even longer, although it's a little cheaper. But still, even when you have launched it, you still, as a discovery partner, you still support that baby you found until commercialization, and you keep looking and making new discovery. What can this have? Can I expand it to new geography? Can we have some new testing, new formulation, and all that? And again, from discovery to launch, really, that's mainly done with within the R&D, with discovery, chemistry, biology. And what are we looking for? Again, here, really, we want people who want to have some opportunity, not only to grow their skill, but also to grow their career. And also people, as Victor mentioned, really, you want to be part of a team. You know, teamwork, team skill is very, very important, because you will be working really with 20,000 people. You will be in a group with people from different backgrounds. Therefore, you want to be very inclusive, you know, to work in that, work and feel comfortable in that environment. And you also want to show initiative, because you will be assigned to a specific group or a specific project. And they expect you that while you are contributing to that group and that project, on the side, you can do something that you are passionate about, you know, which have probably nothing to do with your group or your project, but something that's aligned with what the company is looking for. you have that flexibility to do that. And also we are looking for people who are really solution oriented and can bring some fresh or different perspective on the table. When you come down in the discovery chemistry within the crop protection, really there we have synthetics and natural product. And the major product that we goal that we have there is the field is insecticide, fungicide, herbicide. And again, as I said, we can make those either from nature through the fermentation of microorganism or through some plants, because as we know, most of the stuff has already been made by plants. You just have to take them, extract them, and then go in the greenhouse. Most of the testing are done in our facility here in Indianapolis or around the world. And these are just some example of active ingredient that we have found. And for example, like this inner tract, this is a natural product. And we have launched last year. And this spinosyn also was isolated from a microorganism and mainly used as an insecticide, and it's won multiple green chemistry award. And also is used in the organic market. And again, really in the chemistry, what the expectation here is being able, especially in the synthetic chemistry field, being able to do all the, the medicinal chemistry through the analog, the SAR, all that, because as you guys see in the discovery, it takes a lot of time. It doesn't mean, oh, I'm going to go in the lab and make my one molecule and that's it. No, sometimes you have to make hundreds, thousands of molecules just to find which one is the active, or improving the activity, or improving the physical properties. It takes really long time. Therefore, you want to make all those different targets based on your hypothesis. And again, and we don't expect everybody to know everything. That's why really with scientists that are already there, it's a highly collaborative field. What you don't know yet, you go and ask someone, they can show you how that's doing. And they expect you to publish, really. A lot of publications, especially after they have determined that, okay, this one, even once the patent is filed, they expect you to publish. They encourage that. Yep, you protect it first, because we are in the business of really protecting the discovery we made for launches. And then when that protection is done, then make some scientific publication. Another field also is analytical R&D. A lot of work has been done here. And also Victor alluded here really of the knowledge we gain while we are still in grad school and all that, in analytic, it's a lot of method development. Sometimes we can call from the plant can have some impurity, new impurity that they are seeing. They want to ID that impurity, through LCMS, NMR, therefore a lot of purification will be done. HPLC, reverse phase, normal phase, a lot of mass spectrometry, a lot of different type of spectroscopy, whether it's IR, NMR, and we also do a lot of crystallization also is done here just to get some high purity. Therefore, the analytic R&D also, they will deal with the complaint if, for example, a product is made and it doesn't work the way it's supposed to. Then the analytical group will investigate to see why is that not working? Is the compound not stable? Is the formulation degrading? And they will do all that work. And again, truly it's a global cross-functional collaboration from process, formulation, manufacturing, quality. I mean, all these different groups will use the analytical group. Another group within the chemistry, because the way the chemistry is partitioned is that you will have discovery chemistry, then you will have process chemistry. And the discovery chemistry really at this stage, since it's just for discovery and testing, is just to make compound from milligram to a gram scale that I just want to see is this compound active? Again, any discipline. If you are able to make it in a milligram and answer to that question that yes, it's active, then what we do, once you test because we have different testing cascade. As a chemist, you make the compound, that compound will first go to HTS, the high throughput screening, in all the discipline, insecticide, fungicide, and herbicide. And depending on which discipline that compound is active, because the requirement is different. For fungicide, it requires less compound. From insecticide, it requires a little bit more, but for herbicide is the one that required, you need a little bit like 10 milligrams, whereas the other one with 1 or 2 milligrams, you can get by with it. Therefore, you will just make that one in the lab, send to test. When it gets to a point that, yes, this molecule is really interesting and need to go to the field so we can test it in the real situation, then you will, for the field testing, you will start needing like 50 kilograms, 1 kg, especially that once you are sending to the field, you send it in multiple geography at the same time, because sometimes whatever you will make for a US market might be different the way you formulate it for Europe or for Asia. Therefore, you send in different key geography to see how the compound will react in the field setting. And that work now will be done by the process chemists to make all that scaling. They will do the route, because the discovery route, as we say, really is not optimized just to make what you need. Process route now has to make all the discovery, not only the cost, but also the target. And again, it really need to follow all this, this synthetic process. And one of the most important here is not only the sustainability, but also the low cost and the safety. Because while you are doing all this chemistry, really, safety is paramount in the company. And we also have formulation science. And again, the formulation science, the role here is try to, discover new delivery technology. Once you have the compound, sometimes you need to add an adjuvant to that compound before you can spray it or you can bring it to the field. Why? Because as we all know, once if you just bring the compound as it is on the field with all the sun ray, it might decompose quickly. Therefore, you have to formulate it somehow to allow it even to penetrate the leaves so it can get where it has to go, to even avoid for insect to just chewing it and degrading the compound. Therefore, you will need to do some formulation. And in the formulation group, really, people from different backgrounds, organic, inorganic, physical, material science, chemical engineer, you name it, and they are there. And again, they start really from manufacturing, doing the characterization, and we have to do that formula. And sometimes for a specific compound, you have to look at least for 2-3 different formulations to protect that active ingredient before it can go to lunch. And this group also is a very cross-functional group, because these are the different group that will interact with formulation science or collaborate with them. Now, if really we have to, because as we all know, really, once you are looking for a job, you always say, well, should I go to ag industry or should I go to pharmaceutical? This is a little bit a comparison truly between both. Both of them really, they are, whether you go in ag or in pharmaceutical, both are trying to find small molecule for a specific purpose. In ag, we are trying to do it against insect pathogen or plant pathogen or unwanted weed, or to protect the golf course or some soccer field, really, whatever. In pharmaceutical, as we all know, is yes, you try small molecule that's going to treat certain disease, and all what you do is use medicinal chemistry to get to that goal. in the ACT, what we do in ACT is that our testing will be done directly on the test organism in the greenhouse. You know, we don't do we'll do enzyme only when we are trying to characterize the mode of action of that specific AI. But in pharmaceutical, they will mainly, most compound will be tested in the enzymatic scale, and until they do that compound is moved through the clinical trial. And for the formulation, what we will do, again, we will use the nozzle spray to check for the retention and do the tank mix to say, oh, is this compound, if we take that AI, can we mix it with different compound without injuring? Because the main concern always is we don't want to injure the pharma, we don't want to injure the pharma crops. And in the pharmaceutical, most delivery is either tablet, IV, or injection. And the ag industry is regulated by the EPA. You know, the focus mainly is on the environmental safety and avoid off-target selectivity. Therefore, before a molecule is even brought to launch, really, we do around 300 testing, because you truly want the compound you discover just to act on what you are looking for, not to go and, you know, be nocive to other organisms or beneficial insect, for example, like bee or ladybird. And for pharmaceutical, most work are regulated by the FDA. And again, really, in the process scale, our main concern always is whatever we make has to be affordable, because if it's not affordable, the farmer is not going to buy it. They need to make some, you know, whereas in pharmaceutical, they can just make it. We know if you are sick, you need the medicine, you have to buy it. Therefore, the cost can easily be passed down to the customer. And again, as I mentioned, we need the publication. They encourage to publish a lot. We need to publish. We also have an internship program, and really, when the intern, generally they will join us from May until August. And during that time, they will be assigned to a specific project, and they will be responsible for that project. They really do real research, not just there to help. You are assigned to a project, you have people that help you, but you have to make those independent decision making, provide solution when you hit a roadblock, and then try to contribute to the business success. And at the end of their project, generally they have to give a presentation for what they have learned during their time within our campus. And really, this for them is to really gain training in that environment, get networking opportunity, and also really do some socializing. That's also, sorry. That's also part of it. And while they are doing that, now we have instituted a new program where once the intern come, we try to see if we can rotate them around so that they can learn as much as they can during their time in different settings. They can go here, do 3 months, then go move somewhere else, do another 3 months, depending on what their interests are. Then they will move to that discipline. And this is the recruiting program. Generally, we have some campus recruiting, we have some direct recruiting. And again, sorry, we recruit as different level, technician, MS, BS, PhD, again, in all the different fields that I've mentioned before. And once someone joined join the company, they join it as research scientists, and through the merger now they are just given the number. You can be research scientist at the level 6, level 7, or level 8. And after that, you can move, you can go to a project leader. That means they will give you a specific project, and in that project will be staff. That means you can be a project leader and a people leader, because as a head of that project or the leader of that project, you will be responsible for maybe 5 to 6 people, depending on the position of that project in the pipeline. If it's an advanced project that's ready to launch, there will be really staff. Also, if it's at the beginning in the discovery, they also staff the discovery and the lead project very well, because they want to push those projects within the pipeline. Therefore, as a project leader, you will also be responsible of people leader. And that means you will help them advance with their career. You will have them or review their goals at the beginning of the year. And after the project leader, you have a group leader. And the group leader is just really, you are responsible for a different group of people. And again, group leader, you also review the goals of your project, and you will be responsible during the performance review at the end of the year for each member of your group. And we also have some people leader, that means they are just responsible of managing people but not doing any research. And we also have some bench scientists, which like, really, I don't want to be responsible for anybody. I just want to go to the work, do my job, and go home. Therefore, there are, I will say, really, there are a room for everybody, depending on what you do. If you like leading, yes, you will have a leading role. If you like just going to work and have your work done, you can go and do that. And the expectation in all that is that you will also have some traveling. They expect you to travel at least to 2 conferences per year, and all that is, all costs are paid by the company, just for your, so that you just continue to grow in your specific field. And we also have, once you are in this, whether you are in chemistry, you can be there for a year or 2 years and say, no, I want to go in legal. I want to see how the patent is drafted. They will say, okay, you can go in the patent group, spend a year or 2 years there, see how it's done. Then after that, you can say, no, I want to go in regulatory. Then they will say, all right, you can go in, you can do it as sabbatical or just open position within the company. Therefore, you have the possibility to go in every different area that you want. That part is also open. And this is really, within the group, we have different network, I will say, you know, like you can have the Asian network, disability network, prior network, professional learning, women network, veteran network, Latin network, and African Heritage Alliance. There are a lot of, therefore, once you come there, you can really join whichever one you want, or go in all of them, depending on your time and flexibility, but all are there and all are supported by the leadership and high management of the company. And really, if you want to learn about the opportunity, just go there at corteva.com, and then you will, and again, as a global company, you can find it in almost most of we have labs really almost around the country, really. And go there, you will see job by city, by state, or abroad, depending on wherever you want to be. You can find a position open somewhere, or even join. I can join in Indianapolis and later on decide, oh, I saw a position in France and I want to be transferred there. It's a possibility. Yes, they will transfer you there. And yeah, that will be it for me.
All right, thank you, Serge. That was very good. So I think suddenly we have a time for questions, and please be free to jump in to make comments and also to add to what we've presented so far. But if you have any questions, please go ahead and ask your question. I guess while we're waiting for those questions, there was a question in the chat here from Ashley about the conflict of interest. So the question says, how does faculty get around conflict of interest with consulting projects? Well, really, I think the simple answer to that is it depends. So it depends on what that consulting role is and what they and at the institution. So generally for most research institutions, there is going to be a compliance officer in the research office or in the, under the VP for research that can, such faculty members can talk to about the project, and they send those, contract papers to the lawyers for the lawyers to review if there's any sort of, any state law or university regulations that will be broken or through by taking on the role. But for the most part, I think there is no clear-cut rule that says a faculty member cannot be engaged in consulting. You can if your expertise is needed. It's just a case of you cannot abandon your primary responsibility and focus on that. So you're gonna have to do that on your own time, on weekends or late nights, or or if you or summertime where if you don't have teaching responsibilities. But certainly for the most part that people do it, and they just have to run it by the legal office for clearance. Any questions for Serge? Dr. Waddell?
Yes, let me turn my video on. I'm not hiding. Okay. So my question was, you were talking about using the and different, like in US versus Europe. And my question is, how do you keep them separate? How do you keep something that you develop for the American agriculture for getting contaminated or going over to the European, which they have different standards?
Yes, the way generally is done, especially once we have an active ingredient, we test it. And generally when we test it, the initial at the discovery phase, we will test it in all geography. And once we test it in all geography, then we will take the soil, because the cutoff, for example, if it's groundwater leaching in the US, is, for example, is different than in Europe and in Asia. Therefore, you will do you have the active ingredient, you do the formulation, you spray against your pathogen, then now after a time, you take soil, you analyze it, and you observe, what do I see? And then what is the result of what I'm seeing within the margin that is expected, that regulatory is expected in all these different geography where I expect to sell my compound. And if that's how you start eliminating certain geography and say, no, here is not there, can we find a formulation to improve it? If not, that geography would be eliminated. That's just the way, just looking the cutoff for every different regulatory.
So you don't have it where somebody has banned the chemical in a certain country and some other country they have it, and you have to make sure.
Yeah, and generally the way it goes, once US ban it, everybody else follow.
Oh, okay. Okay.
Once it's banned in the US, that's done. Everybody will just pull it out from their market and say, no, you can't even renew. You cannot renew the package. That's once it's banned. Yes.
Okay. Thank you.
Any questions from the participants? Raymond? Ebrit.
Oh, I wanted to ask, well, it's pretty clear that in the academic path that graduate school is naturally just the beginning. It's just the starting point of really having a career. So someone with a bachelor's, or, who was thinking about doing grad school and then decided against it, would really not even start in the academic path. But Serge, there's not, or you didn't show any of those presuppositions that, oh, of course you're going to go to grad school and then, go on to all these paths. So talk about what what academic experience or what background you expect from someone who would either go into an internship or who would get hired on directly?
Yes, we have actually different type of position, truly. Whether you are a BS, a master or a PhD, there are positions open for every level, to be honest. Now, once someone, for example, we take a student, they came to us, they were just doing their BS, they came and do internship. They do internship and they say, well, I don't have money now to maybe go to grad study right away. After they finish their internship, they can apply for a position in the company. They can come back if they are recruited, they can come back and the company, if they have the willingness to continue, the company can help them further their study. If they want to do a grad study, whether it's a master or PhD, they can help them in that. But per se that, oh, you will need a master or a PhD to be in the lab, we don't have it. Yeah.
So last thing is that Professor Victor already had to field a question about conflict of interest and declaring conflict of interest, but it looks like with all kinds of developments and patents and things that there could be a conflict of interest at anything that's coming out of either Corteva or a university that's associated with Corteva. So how do you address potential conflicts of interest in industry rather than in academia?
Well, in industry, really, every like Dr. Victor mentioned, really, we have an office of ethics and compliance, and every year it is required from all the employees around the world to take a course just on ethics and compliance, and it's mandatory. Which means that because we are buying a lot, we are doing business with a lot of people, they just want to make sure that really, there are even restrictions on accepting gift or giving gift to a vendor, all those things, just to really not put the company in the bad position, really. Therefore, there are some restrictions. If, for example, you say, oh, I have a vendor and I have a sister, or just say a relative or a friend that are working in that company, you have to declare it before you go and buy stuff within that company, because they don't want to discover it later on that, oh yeah, they are buying there because the friend is there, which is not true. But you have to declare it, make it known to the company that, yep, I have a relative there, or I have a friend within that company that's coming and providing us some service. They want to know those, just really to avoid the messiness of it. Yes.
Thank you.
You're welcome.
Oh, sorry. Any other question or comment?
I just had a quick comment, Victor. Do you guys have water yet at Jackson State?
We do. Thank you. It's been back for maybe 3 weeks now. Yeah, it was terrible.
Yeah, I've been worried about y'all ever since I saw it all over the news.
Oh yeah, Jackson is what it is. But they fixed it, and they're still fixing some things though. But the water is back.
Okay.
Yeah. Thank you.
Yeah, I'm seeing a question there about the internship. Yes, the internship position generally there will be online, and people have to send application in, I think, by February of every year, because in February and in April they will make the selection, and around end of April and May they will start coming on campus or coming in the city. Yeah.
People that joined us after we started. Raymond, would you like to introduce yourself and just tell us a bit about you before we wrap up.
My name is Raymond. Once again, I am a PhD student at Mississippi State University.
Yeah. Okay. Now I remember. All right. Yep. Okay, so this would do it for today. If there's no other questions or comments, I invite everybody to please complete this evaluation form, this SurveyMonkey form here, just to evaluate the webinar and tell us a little bit about how to improve what certainly your experience and certainly how to improve the webinar subsequently. And I would like to thank Serge again for joining us for the opportunity to do this with him. Certainly, we have some projects we've talked about, and hopefully that can materialize going forward. And I also want to thank everybody for the joining us. And please, if you have some questions or you like additional certainly to get Serge information, please let me know. I can send that to you. And also, if you'd like to talk some more about my presentation on academic careers, please you can reach me. Just shoot me an email, and we can happy to talk to you about it. And thank you, everybody. And we look forward to seeing you the next one. We don't know exactly when that is going to be, but hopefully we can start the clock again sometime, maybe late summer or in the fall. And I encourage you to please submit the abstract to the NOBCChE meeting, fall meeting coming up soon, and the fall meeting. So please look forward to that request for abstract. And Serge, I want to encourage you, if you want to please participate this year, and that would be a good opportunity to to have all right. And well, someone asked for my email. So yes, that's my email there. Thank you, Ashley and Patty, for putting this together. And I want to thank everybody again for joining us. And I hope you have a nice evening. Thank you, everybody.